Okay, hi everyone. Thank you so much for joining. Today we have Dr. Usama Fayyad, who is giving a masterclass on a practical guide to AI, avoiding the hype, putting the algorithms to work. So a few housekeeping items. The webinar is going to be around 45 minutes. At the 30-minute mark, Usama will start asking questions. So please, throughout, feel free to ask questions in the chat or in the Q&A box. Feel free to raise your hand, and this can be interactive, or he can answer questions at the end. I will now hand it over to Usama, who will begin.
Thank you very much, Zina, and thank you everyone for attending. We are launching on time. The seminar is being recorded, and as an attendee, you will get a link to it for the future. So, introducing myself, Usama Fayyad. I'm chairman and founder of Open Insights. Really, Open Insights was started with the mission of democratizing AI and data foremost. And what I'll be talking about is really kind of reflecting on lessons learned from making AI work for real in the enterprise. There's a lot of people that talk about AI. There's a lot of hype around it. I've been with it for a long time. I've lived through a couple of winters. So my background is I did my PhD in AI and machine learning back in the last decade of the last century, so early 90s. I was then at NASA JPL for 7 years, then moved to Microsoft research, and then Microsoft kind of product and research. At NASA, I got the chance to see how the technology can be super beneficial to specialized scientists in solving problems that were standing honestly for decades without a solution. And that's because they're high dimensional, lots of data, etc. So one lesson learned there is that, you know, even scientists who can dedicate to spend a whole lifetime on one data set can benefit from it. In fact, that was the argument Microsoft used to get me to join them, which is if scientists who can spend so much time on one data set can benefit from this technology, what do you think is happening in the corporate world? And at Microsoft, the main concern was, you know, how do we embed this stuff and democratize it by making it available in the servers, like Microsoft SQL Server. I left Microsoft in 2000 to do my first startup, spun off a second company out of it that got quickly acquired by Yahoo, became the first chief data officer at Yahoo. We invented the title as a joke at the time. It's just part of Yahoo's irreverent title culture, but the title became formal and kind of took on an ongoing basis. After Yahoo I started Open Insights with Microsoft being kind of the first client. In fact, it was work with Satya Nadella, who I worked with for years. He is now the CEO there. And then we had several telcos, including AT&T and Verizon. We had many private equity firms who wanted at the time to evaluate the worth. You know, what's a data set worth as an asset, which brought up all sorts of questions around, is the data usable? Is it available? Is it at the right level? And we'll talk about a lot of those lessons learned here. So let me start by sharing, and in between, I took a break for 3 years. I became the Global Chief Data Officer at Barclays in London, where I learned financial services inside out. And Open Insights today has projects all around the world, all having to do with making data work to enable AI, etc. Let me try to share my screen here, and hopefully you are seeing it now. I can go into presentation mode. So I'll go through the slides quickly. We'll make them available. I'll add, I have a second affiliation as well at the Northeastern University, where I am starting the Institute for Experiential AI, a very ambitious effort. We won't talk about it much today. The focus today is about kind of practically, what are the lessons, how do you avoid the hype, and how do you make AI work in the enterprise? So with that, I would start by saying AI, one of the grand challenges today is making AI work. You know, everybody's talking about it. It is definitely accepted that digitization has taken hold. In fact, COVID-19 pandemic has done nothing but accelerate us towards that digitization. And a lot of interesting dynamics happened there where people were focused on accelerating the workflow, the digitizing the workflow. And a lot was lost in that process, especially in enabling AI. AI has been and remains a great and difficult challenge. Machine learning is a dominant part of working AI today, and I'll explain why. And ML has a huge dependency on data, and that's what's going to lead us into a lot of discussion around data. So despite data being so essential to most organizations are still struggling with the basics of making data work as an enterprise. We'll talk about some of these myths and why they happen. And if we have time, we'll talk about where does the human fit in the AI story, and that's a very critical fit. Really, to me, AI is the fusion of human intelligence with the best of what machines can do, which today is far from what people can do in terms of capabilities. So let's talk about digital transformation for one slide and go from there, right? And I'll use financial services as a setting. By the way, this is not new in financial services. They've been digitizing their world for 7 decades. And now we see the term fintech show up as kind of the trendy term in doing things on the digital channel. And AI has gotten a lot of attention in fintech efforts, and we'll use some case studies later in this talk, in this class, on that. So let me use a simple example. Take something like accounting, right? 60 years ago or 70 years ago, if you were an accountant, you had to have good handwriting, the ability to manage, these big ledgers. You had to have good addition skills in your head, all of that. What you do today as an accountant is completely different. It's a lot higher value. By the way, digitizing that whole accounting workflow has not eliminated any jobs. Actually, if any, it may have impacted the ledger printing industry perhaps, but it has created way more accountants than we ever had in history. So there's an example of something that was digitized dramatically, completely changed in its function, yet many, many, many more jobs were created because the accountant role has become much, much more higher value and much more efficient. And we see this in almost every aspect of life. Now, what happened with the coronavirus pandemic, of course, is we were pushed into the world of digitization very quickly. So, you couldn't go to malls, you had to go to stores, everything was shut down, and that drove everybody very quickly into it. That actually got us over a lot of hesitation and a lot of reticency in kind of picking up digitization. People who were saying, let's wait and see what others will do, got into a situation where if you're not digital, you're either dead or you're walking dead. No time to deliberate, you got to do it. And then people were saying, look, it actually works. It's not as risky as we thought. It's not so scary. It's not so, and we can deal with the issues. And that got us into a much wider acceptance. And of course, as others struggled to digitize, the digital enterprises went into hypergrowth. And we see this in terms of their earnings, in terms of the footprint they have, in terms of their ability to have people work from far. By the way, the results can be very dramatic, right? Failure to take digitization. Kodak, it went bankrupt at 124 years old. Now imagine what they lived through, including the previous pandemic, several world wars, right? And they were the inventors of the digital camera, but they didn't take it, right? They just invented it and let others use it, and that basically completely obliterated their business because they didn't adopt it and hang on to it. We saw JCPenney sadly go into bankruptcy in the last few years. Again, this is after 118 years of successful operation. We also see on the other side people who are excelling with data. I use Vitality. We work with a lot of insurance companies. Discovery Insurance, for example, has a Vitality program where they utilize the digitization to be a win-win, right? Customers can use wearables to show that they have an active lifestyle. They subscribe to gyms, etc. Now that reduces their risk from an insurance perspective, and saves them money while saving, of course, the company money. One of the estimates in 2011 was 4.7 million medical cost savings just from having that digital program. Capital One is a great example of doing this in the credit card business in the US, where their CEO actually says to chase digital for the sake of cost reduction is the wrong thing. It's really about the insights, the targeting, understanding how to service the customer better, and we'll talk about that. DBS is one of my favorite examples because this bank was written off. In 2013, it was like basically almost gone, but they took on a serious digital transformation, and even in the words of their CEO, it resulted in huge turnaround, record net profits, income coming up, and not only going from the status of being in trouble, but becoming now the dominant bank in Singapore. And that's a great example of digitization. Now, something unintended happens. This is where blindness happens. When you digitize, most digitization efforts focus on digitizing the workflows, right? Everything becomes automated. So whether customers are happy, are the products being delivered correctly? Are they satisfying the customers? If they're leaving us, why are they leaving us? To whom are they going? Understanding the market and all of that used to happen while digitization successfully gets rid of that, kind of manual approach, which is expensive and slow and sometimes unreliable, yet it's extremely useful in terms of getting intelligence and understanding. So the question, and then when you eliminate it, you suddenly find yourself blind. So the question is, can you use data, especially unstructured data, and a lot of the data we gather today, IoT and other things, which we will not talk about today, but we can discuss in another masterclass. Can it become our kind of eyes and ears? Can it help us understand what's going on? Can we restore customer intimacy through that? Examples that I like is banks. If you go 60, 80 years ago, the bank was extremely non-digital, right? So the branch manager and the employees in the branch pretty much knew the customers. They knew who was a good customer credit risk, who was not, who's doing well, who is not, who's getting married, who's sending kids to college, who wants to buy a horse, etc. And so all this stuff. Today, these things, which are back office functions, are extremely expensive. A bank like Barclays would spend $100 million, $200 million a year just to do things like KYC, know your customer, just to update their risk systems, all in the hundreds of millions of pounds. So when these guys went digital, they essentially lost that manual touch, which was slow and limited, admittedly, but scale brings the whole challenge of how do I overcome the blindness? How do I understand the customer better? So let's use a quick example here, just to make it real. Kelly is a customer, deposits money into her account. Kelly has a good standing with the bank. Typically, that's the end of the story, right? Now, what is amazing is for most banks, they can actually know a heck of a lot more about Kelly. Kelly has student debt. Kelly just got married. Now, you challenge the bank and say, tell me who got married recently, they'll have a hard time pulling that out. But if you actually use the information that's available to that bank, you can actually construct that picture and know with high certainty, hey, Kelly has student debt. Kelly just got married. Kelly is actually trying to buy a house. So what can I do? Well, that deposit that went with end of story can be a much more interesting story indeed, because it can basically say, hey, I could have offered Kelly a refinancing on her student loan. I could have given offers of a loan to Kelly to buy a house at the appropriate time, etc. And those are important aspects. Now, what happens with digitization, though, it actually produces a heck of a lot more data, 10 times to 100 times more data. And most organizations are not ready to receive that data, let alone utilize it, like the banks. And then becomes the question is, how do we make this data work for the business, right? How do we kind of move into this new economy of interactions, where we moved from transactions, which were simple, few, and very structured, to interactions, which are unstructured and way more interactions, 10 to 100 times more. And by the way, 90% of the data in any organization is unstructured, which I always say 100% of the database is pretty much speak only structured. So without the proper data, we cannot make AI work. And machine learning, which is the only kind of survivor of these winters, needs that data. So let's talk about AI for 2 seconds here, or 2 minutes, and define it. It's a very old concept, by the way. It goes back to even before the 40s. It goes back to Alan Turing and before, mathematicians before him. There's a very relevant body of work under the name artificial intelligence. It all started in the 50s with an academic workshop. Despite much hype and fear, there were few practical successes in the first 40 years. And this excessive hype has actually led to 2 AI winters. You know, today AI is hot. Everybody wants to work on AI. Trust me, I've seen this movie before. That I've lived through periods where people were denying they had anything to do with AI because it had such a bad name because of all the hype that was going on. AI Winter 1 happened in the mid-70s. AI Winter 2 happened in the 1990s. What is AI? Well, it's using computers to simulate human intelligence, simply put. The problem is, with the simple definition is, to this day, we still don't know how to define intelligence. It's still an open problem. In fact, Alan Turing had his Turing test, and we know now it doesn't actually capture it. Even though we have computers that can beat the best chess players, they can play better Jeopardy than humans. Common sense reasoning, something all of us hopefully do, computers have a real tough time doing it, right? And what about machine learning? Well, machine learning is a subset of AI. It has to do with algorithms that change behavior based on data, based on observations. And a lot of very interesting things have happened in machine learning because data has enabled it, basically. You have examples of how to do something, and you let the computer figure out how to do it. Now, the hype continues during our third wave of AI, right? And you can see many articles. You know, you hear about this. People are basically, you know, in the first AI winter, the US was afraid of Japan. They had a program called 5th Generation Systems. Today, everybody's scared of the China 2030 AI. And everybody's saying, well, we're all going to be useless, jobless, brainless. Very far from that, actually. The state of AI is very, very far from replacing humans. It is at a state where it can help with certain tasks, and we'll talk about that. So my personal prediction is winter is coming. There's going to be another winter because there's been so much hype. The good news, though, for this class and for people working on AI is most AI is machine learning applied. And machine learning has somehow managed to survive both winters before and will likely survive the next winter. Now, why is that? Why has it survived? Well, I like the quote of my friend Peter Norvig from Google. He basically says, and this is accurate, we don't have better algorithms in AI or in machine learning. We just have more data. That is what has changed. And that data has enabled us essentially to do regression. And machine learning is nothing but very fancy nonlinear regression instead of the traditional linear regression you think about. Despite this, you know, you still have 85% of big data projects failing, according to Gartner. And as I mentioned, 90% of data in organizations is unstructured, yet most databases can only deal with structured. So most organizations are still kind of ignoring 90% of the data available to them. This is the size of the opportunity, in my opinion. So there are lessons learned. I'm going to share 5 lessons with you. Lessons learned in doing pragmatic AI in enterprise intelligence. Lesson number 1 is you need to reduce the problem to one where you have complete knowledge of the domain, right? And that's where you can do reasonable reasoning. That's where you can avoid doing silly things, which AI algorithms are infamous for doing. Complete knowledge sounds impossible, but if you really, really narrow the domain, like if you're playing chess, you can have complete knowledge. And there you can build systems that can beat humans. Checkers or any of the games players are examples of that. But that also generalizes to factories, right? If I have a setting and I'm working on a certain machine in a certain context, I'm not moving around, the environment isn't changing much, I can do it probably better, faster, more reliably than a human, right? Would I call this intelligence? No. But it requires a lot of robotics and a lot of AI and a lot of image understanding and kind of image parsing, etc. So it's not negligible. Lesson 2 is data is a necessary enabler for practical applied AI. So make sure your data is captured and managed as an asset. And typically the question I ask most organizations is, what is the state of the data? Is it really an asset that you can utilize? And most organizations have challenged with that, and we'll talk about that. Or is it a liability? I mean, in most organizations, data is sitting there waiting to be internally leaked or externally hacked, and therefore nothing but a liability because they're not really using it to drive the business and benefit the business. And we'll come back to that. People talk about data at rest being secure, and we solve that problem. Far from it. I mean, I use the example, the recent one from Facebook. And I use the Facebook example because Facebook is one of those kind of newer companies no legacy systems to blame, lots of data, of course, and they are advanced in utilizing data. But in April, for example, there was a leak of 87 million. And usually when I see these leaks, I always say this is the tip of the iceberg. Sure enough, by June, there's another additional 120 million records. And even getting worse, by October, it was revealed that many accounts got seriously hacked, including Mark Zuckerberg's and his COO's account. So these things are still open problems, honestly. Don't think that data at rest is a solved problem, but we have interesting approaches to keeping it secure. Lesson number 3, AI and machine learning expect data to be in certain formats. Ensure it's convenient to leverage the data quickly and experimentally, right? The art of pragmatic AI and effective data science is understanding that the algorithms are dumb, fragile, and brittle. Brittle is the word we use as kind of, that's the anti-robust, right? So it's not robust, it's brittle, meaning if a small change can cause the whole thing to collapse, and typically collapse in a very non-elegant way. It's not a controlled collapse. It crashes basically, or pretty much functionally. Most of the action is in how the data is represented, right? And this is what kind of young data scientists don't understand when they first come out of school. They think it's about hacking at data with an algorithm, and it's not. It's really about understanding how limited and stupid the algorithm is, right? And then adjusting for that by representing the data correctly. I'll use some case studies here to help you understand what's going on. So I'll use one case study with one of the large car manufacturers, with Chrysler. This was about predicting market demand, utilizing just sales data. And I like this example because it shows you the power of representing the right data the right way. So the whole idea is, can you predict how many cars are going to sell, right? And they were doing it nationwide, they were doing it at a gross level, and they were getting very low accuracies in the predictions. Well, what did we do on this problem? Well, we did this, what we called at the time the mega analysis, right? We actually imagine having every vehicle model with every kind of option package, every zip code. It's actually not a zip code, but a market area, which is usually a grouping, a small number of zip codes. It represents a dealership area. And then every week and every month, right? So that cube alone, within it is a whole bunch of time series, right? That measures number of sales, number of hand raisers, people who asked for a quote, browsers, price and equip. This is what you configure on the web, for example, and then get a quote, etc. These are examples of what's in there. So you have the sequences in every cell, and you have hundreds of millions of these cells, right? And the whole idea is to try to predict what is the demand. Is it in 3 weeks, in 6 weeks, in 8 weeks for these cars? The short answer here I'm going to give you, which took us a long time, but I'll tell you how we made it work, is very accurate prediction in the 4 to 12 week range. In fact, eerily accurate for 2,500 regions by these car models. And I'll tell you the big observations here. So the biggest observation of what turned this problem from unsolvable to solvable sounds silly, sounds ridiculous. It is the fact that sales are reported weekly. Yet the population in the United States has been trained to kind of buy cars at the end of the month. And there's a very simple observation I ended up making at one point, which is, hey guys, weeks do not align to months. So something that looks like it's systematically growing until end of month, then it drops again. Then it systematically grows again until the end of the month, then it drops again. That doesn't align with how you measure the data. The data gets reported by JD Power across all the sales, and that's what the car manufacturers look at. And of course, in that space, the data looks very chaotic, extremely impossible to predict. But once you have that insight and you start adjusting and saying, oh, this week broke a month, this week happens to be half in one month, half in another, there's a holiday here, all those adjustments actually yielded amazingly accurate predictions. And I'll spare you the story of how we implemented the impact, which is through influencing their incentives program, which was the easiest thing to influence. So once you solve the problem, the prediction problem, that's not the end. People look at it and admire it, but they can't act on it until you figure out how can they use it and how can they make it actionable, right? Lesson 4 AI operations should model processes and aim to understand intent. So not just record the data, but understand what the intent is. So the question I have, for example, is do you have an architecture for customer intent, right? Some companies have it easily, right? If you're Google, you're lucky because, and I'm not saying what they do is easy, but at least the part of figuring out customer intent is easy because the customer is actually telling them what the intent is. I'm actually typing it in the search box. Aha, Usama is trying to buy a car, or Usama is trying to fix a computer, etc. Most businesses have to infer this. They don't have it readily made. So I'll use a couple of fintech studies to tell you how these are inferred. This one came with work at Barclays Africa, actually. The retail bank wanted to say, hey, people kind of tend to overdraw their accounts, and we want to catch them before they overdraw. We want to save them from having to pay these fees because it's a bad customer experience, and we want to give them a warning, right? So that we created a system that would predict, hey, we're looking at your inputs into the account, meaning your income sources and all of that, your typical spend habits, and we'll tell you, we'll send you an SMS message at the right time saying, in 2 weeks, we think you're going to go into overdraft. Click here to do something about it to prevent overdraft charges. Now, when you do an SMS campaign at a bank like Barclays, a 1% response rate is typical. 2% would be like you hit it out of the park. 60% response rate, right? This is how a targeted message in the right time, leveraging real-time streaming, can actually make this happen. And we used open source streaming platforms. We used Kafka to do this. 80% favorability rating, etc. Two other derivative applications of this one was influencing customers to say, hey, you didn't have to go to the branch. When one bank tried to do this in the UK, they basically ended up crunching through the data, and the latency was so high that they ended up sending their customers messages saying, hey, remember 3 or 4 weeks ago when you visited the branch? You could have done this online. Instead here, because we had the real-time platform, the messages would go to somebody when they go to the branch, right at that moment. And then I'll say, this is very relevant. I'll pay attention to it, and it influences behavior more. Again, the timeliness is very important. And then credit limit increase. While you're shopping, this is in South Africa, you'll get an offer that says, okay, I'm willing to add 500 Rand or 1,000 Rand to your credit limit. Click here to accept. Again, very high acceptance rates compared to typical one. Another one here about intent and understanding what's happening with a customer is a favorite example I have. This is with one of the biggest retirement management firms in the United States. And the problem statement is the advisors spend about 20 minutes interviewing clients and saying, hey, how have your goals changed? Any big changes in your life, big changes in your profile for risk, all of that. That takes about 20 minutes. What we did here is this is work with a company that got acquired now. It's a chatbot company called Abe.ai. But what we did is collected that data and said, okay, you know what? Can we leverage the conversational AI platform to reduce this? And we managed to actually get this reduced to a 5-minute interaction instead of 20 minutes, which was a huge win. It was a win for the customers because they actually had a great experience. It's 5 minutes instead of 20. It's a huge win for the advisors because now they can do many more customers in the same time with less effort and less repetition. And by the way, just to make it clear, this is like a 5-week, less than 200K. And the organization estimated that there was a $5 million productivity gain of advisor workforce annually just from deploying this, just from reducing it from over 20 minutes to 5 minutes, in addition to getting better NPS and customer reviews, etc. And by the way, a trick to make this happen is about understanding the customer. So you can't have a discussion that kind of collapses once they go off script, right? So you can actually understand what happens, you have context, and you can respond intelligently to questions. I'm going to move fast through this. I shared with you the first 4 lessons. The 5th one, which is perhaps the most important, if anybody comes to you and says, hey, I have an autonomous AI or I have a general AI, kick them out of the room immediately because they are not telling you the truth. This is really about human-centered AI. This is systems that help humans perform much better, and having the human in the loop and building the system to help the human and getting that feedback. By the way, if we have time, I'll come back to it. Even Google uses that approach, where the human feedback is an essential part of deciding which queries get ranked and how they get ranked when they answer your queries, right? Now, you go to a typical company and you say, an enterprise, what's your data situation? What do you expect from data? Everybody says, I want it to be reliable, affordable, timely, accurate, comprehensive, unified, accessible, easy to understand, easy to embed in the business. Sounds great, doesn't it? Well, reality though, is you'll find that the data is unreliable, very expensive systems, batch and slow, questionable quality, incomplete, no unstructured data story, fragmented, difficult to utilize, confusing, and unusable essentially in the business. Now, big data it promises to fix this, but it also promises to introduce all sorts of other issues. So we need to approach it as everything else with care and understanding. Here's an example. We built a big data system at Barclays, mainly to work with the cybersecurity folks who wanted to bring data from all across the bank, many events, internal, external, put it together and help them investigate issues when they come up. What happened once we built this, and we built the central platform as a data as a service, right? Utilizing open source and Hadoop, basically, Cloudera. Well, the minute we built it for cybersecurity, actually financial crime came and said, we can use this data and we don't have access to it elsewhere. Then fraud detection folks came and said, hey, we want to leverage that. Then soon after that, marketing and risk. So a lot of the functions suddenly, even though it was built for one purpose, but because it was built right and it was built affordably and in a reasonable time, a lot of users showed up out of nowhere because they had that demand and they were having trouble getting to their data at the right level. Over time, at Open Insights, we kind of evolved because we've done this many times, our 5 R's of data strategy. What is the revenue opportunity, or what we call the catalog of opportunities? How do you structure it very quickly? How do you map it to relevance to your business and your users and so forth? How do you build it to a reference architecture? So once you decide these opportunities need to get pursued according to this roadmap, according to a prioritization, how do you build iteratively to a reference architecture? And then regulation. Can I use this data? Can I not? Can I watch out for issues of unfair AI, biased AI, all of that stuff? We lump that under regulation. So those 5 R's are extremely important. And we kind of have done this exercise so many times that now we can get it done in weeks instead of months or years for very large organizations. So the real question then you have to ask is data under control? Is it driving business growth? And the problem, big data, I mentioned this, can lead into a big mess very quickly. So you need to have things like data governance in place. You need to have things that, data architecture and how it gets built right, and how do you utilize it. You don't just slap everything together, dump it in a data lake, and then hope for the best. What I assure you will happen in that case is a data lake will turn into a data swamp, a toxic swamp, and will cause you more headaches and problems in even understanding what the heck that data is about. So you got to do this thoughtfully and with the right approach and the right data strategy and the right data architecture. And that enables you to kind of derive value from the data and do it. To me, the only solution I've seen working through my 3 decades working in these fields is to build it as a data as a service. So data is a utility. You don't build your own data solution, it gets built in a centralized way, and certain restrictions imposed on it. The data governance is built in, the standards are built in, so that avoids the whole mess. And of course, it has to have a microservices API. So that's a whole area, data as a service. Happy to talk to you about and answer how do you do that. But this is a key. If you have a data as a service, you can enable a lot to happen. We learned a lot from this. I'll share with you our quick learnings here. Typically, these projects are kind of breaking the budget, but if you use environment as code and open source, you can really reduce the budgets by a factor of 10. 10x faster, 10x cheaper, which is 100x advantage is what I always tell the team. Garbage in, garbage out. If you don't build in data quality, preferably at source, you will never solve the problem. And you got to build in the governance, because once you have data quality, you got to stay in quality. Otherwise, you'll stray off of it and you'll be in trouble. Structured data only is a bad idea. You need to have a real story for unstructured data, especially documents, contracts, other descriptors, and often doing things in document stores is much, much better than trying to do them in structured databases, which are not appropriate for image data, for voice recordings from the call center, all sorts of applications you don't think about right now that are enabled through the unstructured data and the big data stack. A recipe for failure is you try to solve the whole problem. You don't want to ever do that. You want to do slices of the problem. You want to do it iteratively. So our formula for building a data as a service is we set a 12-week target. We say in 12 weeks, we must deliver this business value, prioritized through our catalog of opportunities. Once you deliver it in 12 weeks, you don't build it as a point solution, you build it as part of a reference architecture. So that's the other trick. You got to have both going. So you're building it in thin slices. You know, use case number 1 might bring in 10% of the data. When you add the second use case, you might bring in another 20 or 30%. By the time you've done 5 or 6 use cases, not only have you delivered 5 or 6 very valuable use cases to the business, but by now you've brought 80 to 90% of the data into that data lake, or what people are now calling the data lake house. And then finally, lack of talent, right? How do you partner with the right people to get the talent introduced to these new technologies, getting used to using it the right way, getting that right culture that says, here's how we approach it. You know, we don't boil the ocean, we do it in slices, we do it in a systematic approach, etc. That leads me, and we talked about kind of understanding the customer at a deeper level. I'll use an example here from telco, for example. How does a typical customer view the telco? Well, they view it very transactionally. Hey, I use their voice services, I use their data, I send emails, I do this kind of stuff. You ask the same question of the telco. How do you, telco, view your customer? And you get an equally transactional view. Oh, you know, they topped up here, they didn't pay here, we had to provision extra services for them there, they use our wallet. Hey, they maybe even open an account with us, they have connection issues. Very, very transactional view. In reality, a telco gets to see all sorts of stuff. They have the privilege to see life events, which are low frequency, high value, like you're trying to buy a home, you're getting married, you're buying a car, you're getting a degree, you're having a child. And they get to see the day-to-day stuff. You're trying to commute, you're paying utility bills, you're trying to do entertainment, shopping, your travel, now that traveling is back. So all of these things are visible. They're not visible directly, you have to derive them, but you have to have that architecture that allows you to get to the intent. What is the customer trying to do? And do I understand them at a level that allows me to know what they're about? If I know, for example, you're trying to grow a family or send a kid to college or getting a degree, the marketing message is different. The way I get you to do recontracting or renew with me is different. The way I answer customer service is different, etc. So these are all very, very important things to understand. And the key is you have access to them, whether you're a bank, you're a telco, or any business, in fact, that has any transactions. The way we like to do this is you organize these together in what we call a customer 360, organized by subject areas. These subject areas represents tens to hundreds of variables. But basically, they kind of give you a quick and sufficient image of your interactions with that customer. This is our unified customer view, which often is called customer 360. Once you have it, you'll get many things to understand here. You can position much more powerfully. You can target communications. You can enhance your customer acquisition, get customers who are like the ones you'd like to have, strategic pricing, competitive edge, and of course, customer retention and so forth. An example of somewhere where we deployed this is with a large multinational telco, where we basically actually started all the way from a data strategy to actually building the customer 360, as well as building data as a service that fed into the customer 360. And through the steps, you get business benefits, like doing things like predictive recontracting much better. You can expedite business case rollouts because now you can test them very quickly on known persona and known customer attributes. The data governance is built in, etc., so you don't have to waste time on it. A lot of it is done by technology, and of course there's technology benefits. And we won't spend our time here, but instead of getting lost in a lot of the technology, you actually have a data as a service. It's built as a utility, it has APIs, it's factored correctly, so you don't get stuck with a lot of this. Let me summarize and wrap up here and move it to questions. Some of the key themes in this talk: AI is becoming an imperative in the digital age, yet very challenging to make work. If you don't have data, you probably don't have working AI. I assure you of that. So because of the dependence on machine learning. So the question is, are you collecting and putting the data together? Digitization results in a lot more data, which is a good news for AI and very, very bad news in many organizations because they're not ready to deal with that much more data and they don't know what to do with it. And therefore, they can't even leverage it for AI, let alone just keep up with it. Getting the data story right is therefore a key enabler for business insights and for AI, and I don't need to argue that. And there is a rational approach here to getting to the data assets, not liabilities. And it requires a data strategy. It requires a data as a service built with built-in data governance, an incremental way of building it so that you're not trying to boil the ocean. You're doing it in the context of business meaningful use cases, delivering business to the data at every step, which is very important because it keeps the business engaged and it increases the demand for these kinds of solutions. The dynamics of AI applications to keep in mind: AI is highly dependent on machine learning, like we said. Machine learning is very dependent on data, and AI applications are subject to biased, unreliable data, serious brittleness, and especially in the face of changes, and changes happen all the time in business. Disruptions happen all the time. What is the most expensive part of building a working AI applications? I ask this question of many people who do AI and therefore machine learning. And they give me the wrong answers typically. The most expensive part is actually getting your hands on correctly, reliably labeled training data. So you need to collect data, but then you need it labeled. You know, here's the right answer in this context for this case, right? And you need to do this systematically. And this is where you have the human in the loop. And then that is the most expensive part of any machine learning project. In the world of autonomous navigation, in the world of search, this is where billions get spent, just getting that reliably trained, high quality data, which is the key ingredient to make AI work, because AI depends on machine learning depends on data, and labeled data, correctly labeled data. So keeping that working is keeping that data fresh, keeping it up to date. And a lot of people don't think about that. Unfortunately, the literature doesn't talk about it. Nobody tells you the most expensive part of machine learning is getting to the right labeled data, when in reality, it is the case. Right? That is the biggest bottleneck. So I'll end on a big note here. You know, you see me with this background. So what is this divide, right? There is the world of AI haves and AI have-nots. There are several companies who have invested so much in AI over the past 2 decades, maybe 1 decade. And because they're doing AI, they need data, and because they need data, they do better AI. And so good AI begets more data, good data begets more AI. If you're and by the way, there's maybe 20 or 30 of these companies worldwide. These are the AI haves. Then you have the rest of the market, 99.999% of the businesses who are the AI have-nots. If you're a retailer trying to compete with Amazon today, good luck to you. They've been at it for 20 years. They've looked at all sorts of aspects. They learned so much. Same with, you know, autonomous driving. Same with many applications, recommendations for movies, all of that, ride sharing. So the world is sitting, you know, over on this side here, watching this divide grow bigger, and saying how the heck we cross it. And really, we started Open Insights, and this is, you know, our our ethos is about democratizing this. How do we enable the crossing quickly, reliably, with a lot less budget and a lot less investment and so forth? And this is exactly what we try to do here. With that, I probably want to end the talk. I give you my contact information, of course, and the channels that are available online. Hopefully you found this information useful. The plan was to end at the 45-minute mark and open it up for questions. So please make sure you type up your questions. We'll make a video available to you guys if you want to repeat it or share it with colleagues. If you have any questions, type them up in the chat or in the Q&A box. And I think Zina is going to start sharing the audience questions back with us. Thank you for listening again, and I'm happy to answer any questions.
Yep. Thank you, Usama, and thank you to everyone that has submitted questions. We probably will not get a chance to answer all of these. So if we do not, we will be writing them up and it'll be posted on both the Open Insights page and on Osama's personal LinkedIn. So the first question is, how do you see different regulations affecting the ability of organizations to really fully utilize all this data they have in advanced AI use cases?
Yeah, I actually think, by the way, my view is that regulation is a tailwind, not a headwind. I could tell you I lived that story. You know, people initially see regulations as a problem. Oh, they're limiting us. Oh, they're doing this. Actually, if anything, they give you a framework and they enable you to begin to understand what's okay and what's not, right? So a regulation that says you must have consent from a customer to use their data is actually a good thing, right? Because it actually, you know, once you use it, you're not going to get this backlash of customers saying, hey, you used my data without my permission, which can be reputationally disastrous and can cause all sorts of creepy outcomes. Many other restrictions are a good thing. Now regulations are evolving and we need to be involved in kind of informing the regulators. In my opinion, regulation always should follow innovation, not lead it. But in many cases, it's a good prompt to do better data. In banking, I can tell you, for the back office, for things like risk and finance and so forth, regulation, while viewed as costly and very, very expensive and a huge overhead on banks, it actually helped them modernize and push them to modernize their data systems, their understanding of their customers, their understanding of their risks. And we have much more reliable and healthy banks today than we did, you know, pre the financial crisis, by the way. So it's a double-edged sword. Right? Sometimes regulation gets in the way. Many people use the example that, hey, China can just use data without permissions. But guess what? There's plenty of data in the world. There's plenty of data available. You know, talk to me, whether at Open Insights or at the Institute for Experiential AI. There's many interesting data sets you can tap into, including, you know, one of the things we do, for example, is we crawl a lot of the publicly available databases to kind of build a profile to help us understand the socioeconomic environment of places. Like, let's say you're a chain of stores that's trying to open a store somewhere, or a branch for a bank, or deciding your next location. Well, guess what? You give me a zip code, I can give you about 20,000 variables, all derived from publicly available data, right? That can actually, and it's okay to share it, right? It's shared at the right level. It's never at the individual. And there's very good ways to deal with that issue. So again, it shouldn't stop us. It should encourage us to do the things right and avoid the big pitfalls. Other questions?
The next question is, I see lots of customers throwing the accountability of managing this data conversation on IT, CDOs, or CTOs, and it rarely leads anywhere. What suggestions do you have for businesses to adopt a different model of change management to really transform how they look and use data and AI?
Yeah, this is very tough question and an excellent question. I'll share with you kind of my experiences, right? Yes, they typically will dump it on a CDO, unfortunately, or delegate it to. You need to have the right chief data officer in place, right? If you have someone, in many cases, remember I was the first chief data officer, and my job at Yahoo was to basically be the voice of data at the executive table. And I'll give you an example, right? The discussion I was having with Yahoo at the time was saying, listen, I've looked at what we're doing and how we utilize data. We're a very product-centric company. They had 120 properties, like Yahoo Mail is a property, Yahoo Finance is one. Very product-centric. Everything is around the product. What if we try to understand the customer who uses multiple products? You know, Yahoo Finance, Yahoo Mail, Yahoo IM, etc. The minute we did that change, the minute I convinced them that going to customer-centric will unlock a lot of value, it sure did, right? There was an additional about $1 billion, both in traditional targeting as well as behavioral targeting. Behavioral targeting went from 20 million a year to 400 million a year. Just because suddenly we understood that this customer is looking for a car, or looking to get a loan, or open a brokerage account. And usually when you target them, say on Yahoo Finance or Yahoo Cars or Yahoo Autos, you run out of inventory very quickly. These are limited sites. But that same customer goes to Yahoo Mail, right, to check their mail many times a day in those days. Well, guess what? The fact that they're interested in a car or whatever, it didn't go away, right? So having, and therefore you can target them, and you can, for the same ad that got sold at like 10 cents a CPM, suddenly it's selling at, you know, $5, $10, $12 CPM. So it's a factor of, you know, 20 to 30 to 50x the same revenue from the same inventory. I just said an example. So you have to understand what is possible with data, because you can say we can do this, but then you have to be able to deliver it. And you have to understand what is possible in the business and do it in a way that is good for the customer, right? In this case, targeting ads is actually not bad for the customer. I distance myself from the bad practices of behavioral targeting. I mean, today, if you search on something, God help you, you're going to be targeted with an ad for that thing for the rest of your life. That is a bad example of bad practice. But doing it in the right moment, instead of showing you irrelevant ads, I'm showing you relevant ads in the moment, and it lasts only the appropriate amount of time, is a better experience for the customer, is a better experience for the advertiser, is a better experience for the publisher. Now, that discussion needs to happen at a level where the CDO understands how to speak the business language and understands the limitations and capabilities of technology. That combination is rare, and I encourage organizations to get that kind of CDO who also has the execution power, the ability to actually build systems. Because a lot of what happens typically is IT, they're trying their best, but you know, the primary mission for an IT team typically is keep the trains running and get the apps going, and data is almost an afterthought in many cases. So they're trying to do their best with data, but they're not data specialists. So you must have also those data specialists in place that will help educate the business. So the last component of this that we had to do in many of our clients, including some of the big telcos and big banks, is the culture part. How do you get a data-centric culture or a data-aware culture, right? And I always say culture will eat strategy for breakfast. So if you don't have the right kind of data academy, the ability to explain why is the data important, how do you use it, how does it fit in, and it fits in across the board, right? That is the biggest way to kind of get the organization to tune in. And of course, my favorite is the best way to do it is to show it successfully. That's why I'm a huge fan of very short term. 12 weeks is a magic number. Show me value in 12 weeks. Do whatever you need to do to get that answer in 12 weeks. And if your problem needs more than 12 weeks, guess what? You have scoped it wrong. And you need to go back and scope it right so that you can give that answer quick enough so you gain the right to do more. You gain the credibility with the business and with the technology teams, and you kind of notch up those successes. And in the process, hopefully, you're building to a reference architecture. You're not building it as point solutions and creating a mess. No, right? You're building it to a reference architecture, and you're working with people who know what they're doing and helping you on that journey. So it's really important to partner with the right folks who really understand data to do it correctly, and AI, of course. Yeah. Other questions, Zina?
So we have time for one more question. If lesson one is seek controlled and knowable spaces, shouldn't we actually be trying to remove the human element at every step? Does human in the loop simply mean conceptualizing customers as components of a machine or something more?
Can you repeat the first part of the question? I think I heard the last part.
If lesson one is seek controlled and knowable spaces, shouldn't we actually be trying to remove the human element at every step?
Yeah, that's a great question. So lesson number one, I like how you put it, but the way I said it is make the application as narrow as possible, because the narrower you make it, the more likely it is that you will have complete knowledge of that subdomain. And therefore, the more likely it is that you'll avoid your algorithm doing silly stuff because it's very controlled, right? Now, does that mean removing the human from the loop? The answer is no, in both senses. Here's what I mean. By making it super narrow, you still need the human to give you the guidance. Like no algorithm really has true complete knowledge. No algorithm really knows how to adapt to a new situation. I say this today, and it hurts me to say this because I'm an AI researcher, right? And my roots. This is a failure of our field. We cannot adapt automatically to changes. We need guidance. it's easier to get guidance by humans showing us examples of what to do in the right context and what action to take. And that's what I mean by the human in the loop, right? I don't mean that the human has to continue to do it. Inside the loop, there's a lot of work that's mundane that, in my opinion, should be done better by machines. There's a lot of work that requires human judgment every once in a while, and that should be done by the human, and that's the human in the loop analogy. And to me, it's not like the human as part of the automation. It's really the automation to help the human, right? I'll give you a quick example. X-rays in the US, right? It used to be that X-rays got read by radiologists who were all over the country. Then somebody had the brilliant idea of saying, well, let's group the radiologists together in a big center, and we just send them digital images, and we specialize in reading. So that happened. One of the areas is outside Denver that does this. Now you have them all centralized, right? So then people get the other idea, which is, okay, when you read an X-ray, well, it's a function. Sometimes you're tired. Sometimes you ignore something. Sometimes you miss something by mistake. Sometimes you're having a bad day as a radiologist. So what do? Well, we utilize all this data, all these readouts from the past, to train algorithms to automatically figure out a recommended kind of reading of that X-ray. Now, you don't send that X-ray from the machine directly to the provider, the doctor. You actually have the human being, the radiologist, look at it and say, okay, I agree with it, I sign my name to it, right? That involvement now has done something really important. It elevated the function. It actually allowed the machine to kind of scan and look for anomalies, and often it will find anomalies that are not anomalies, and that's when the radiologist will say, no, 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 this is fine. You're wrong, machine, right? That is gold, right? The fact that they told you this is wrong, now that allows the algorithm to adjust and say, hey, I got it wrong here. The fact that I missed something is another one, right? But now what you have is a read of the X-ray that might take 2 minutes instead of 20 minutes, and is less susceptible to kind of missing the obvious cases and all of that stuff, or sloppiness or error or clicking on the wrong thing, whatever. So it's very, very important to kind of have that interaction be kind of on the virtuous level, which is you're reducing the, one of my other favorite quotes is, AI is not about replacing the human with a robot. AI is about taking the robot out of the human, right? And that's where the right fit happens. And that's what I call human-centric AI, with the human in the loop in the right way. Hopefully that answers the question. And this is exactly, by the way, what we are pursuing at the Institute for Experiential AI at Northeastern University in a big way. Zina, any time for one last question? We have 2 minutes left.
Sure, we will do a quick one. Pipelining is also a challenging task. I would like to ask, what framework / methodology do you use and/or recommend?
Pipelining. Okay, so that is not a short answer to the question, but so what I recommend is, I'll give the short answer here and we can elaborate online, because we don't want to go over time. In pipelining, you basically need to lay out, I'm assuming this is what you mean, is kind of lay out the tasks and basically saying, look, you have different parts working on different tasks, and there's a stream of these tasks happening, so you get parallelism and throughput because you're pipelining. Those are typically the best settings to do kind of injecting AI in the right places, right? It could be from very simple RPA, like robotic process automation, because now, think about it, a lot of the lessons are satisfied in that pipeline, right? The task in each step of the pipeline is very narrow, it's very known, it's very well understood, it's very controlled, and often the use of a human in that loop is not appropriate. Now, I'll give you a quick example from something we did at Barclays. There's something called standard settlement instructions. Well, what is it? You get a set of instructions that say, okay, somebody needs to pay somebody this amount, wire it to this account, right? And you have to type in all this stuff, right? Well, guess what? Machines, because there's only like 60 or 80 forms on the input and a few on the output, well, machines are much better at kind of understanding the forms and figuring out what the numbers should be and accurately transcribing those numbers. That avoids what we call the fat finger problem, right? If you type the wrong digit, I used to get calls from the CEO of the wealth business, for example, saying, Usama, your team in data operations has sent 10 million pounds to the wrong account. You're going to be with me on a daily call with the customer until their money is back in their account, right? We're going to get it back and all that. Well, we can avoid all of that by having a machine do most of that work, which is part of the pipeline processing, and then have the human check it and double check that it's okay. And if you speed it up enough, in that case, they actually had 2 humans check it, because we cut down the time from 20 minutes down to like seconds, right? So now you can afford to have 2 humans double check that, and then send it off, and therefore reduce the errors, reduce the issues. And that's an example of a task that's better done by computer, but you still need the human intervention. You need them to double check it, because every once in a while you'll get it wrong, you'll miss it. You'll do the wrong thing, and that's when they catch you. And when they catch you, that's the opportunity to have the gold, right? The input for improving your training set, so your algorithm gets better and better and better. And that's the human in the loop done the virtuous way. I think we have hit our time limit, so I want to thank everybody for attending. We will send you the follow-ups and a copy of the recording. And of course, happy to follow up and answer any questions or explore any areas of mutual interest. Thank you, everyone, and back to you, Zina.
Thank you, everyone, for taking the time to attend today. If you have any additional questions, please submit them to marketing@open-insights.com, and we look forward to getting you the video and the answers in the next few days. Have a good rest of your week, everyone.